In this lecture, we'll talk about Python's Dataclasses module, which is an essential tool introduced in Python 3.7 for simplifying class creation. Now, from a functional programming perspective, Python's Dataclasses module presents a unique blend of functional and object-oriented programming paradigms. Functional programming emphasizes immutability, simplicity, and the use of functions as first-class citizens. Let's explore how data classes in Python align with these principles and support a more functional style of programming. In functional programming, immutability, the idea that data should not be changed after it's created, is a key concept. Data classes support this principle through the frozen parameter. When you define a class with data class frozen equals true, it becomes immutable. Any attempts to modify its attributes will raise an exception. This immutability aligns with the functional programming principle of creating predictable and side effect-free functions, as we've discussed in earlier lectures. For example, in genome pattern recognition, a context that we'll be following quite closely in the examples that we do further on in this course, an immutable data class could represent a DNA sequence. Once a sequence is created, it cannot be altered, ensuring data integrity throughout the analysis. Functional programming often involves passing data through a series of functions. Data classes serve as efficient and readable containers for data, making them ideal for this purpose. Each data class instance can be seen as a simple data structure, quite similar to tuples, with named fields which can be easily constructed, deconstructed, and passed around functions. They automatically generate init, wrapper, and other methods that simplify the creation and debugging of these special data structures. In streaming log processing, for instance, log entries can be represented as instances of a data class and passed through various functions for filtering, mapping, and reducing operations. While data classes are inherently object-oriented, they can seamlessly interact with functional programming concepts such as first-class citizens and higher-order functions. Methods of data classes can be passed around as first-class functions. For instance, in stock price anomaly detection, methods of a data class representing stock information can be used in conjunction with higher-order functions to process and analyze data in a functional style. So in conclusion, while Python's data classes are a feature of its object-oriented capabilities, they complement functional programming by supporting immutability, easy data encapsulation, and compatibility with functional programming techniques. By facilitating the creation of simple, immutable objects, data classes enable a style of programming that is more declarative and less prone to side effects, aligning well with functional programming's emphasis on purity and immutability, as we've been discussing in this and earlier lectures. Let's now head over to the hands-on coding session to see data classes in action. See you there.